Assalamualaikum and selamat sejahtera. We want to present our case study Geotechnical Engineering DCC30093. Our case study is about Batang Kali campsite. So this is our member Afika Amni binti Amran, Nur Syairah binti Yusri, Nur Ain binti Obaka, Dura Adriana binti Murad. So now let me look the introduction of landslide is when rock, dirt or rubber move down a slope caused mainly by gravity. There are 5 main types of landslide: falls, toppers, slides, split and flows. This can happen to different types of materials like rock, dirt and soil. Landslide can happen when the force pulling things down like gravity are stronger than the materials holding the slope together. Several things that trigger a landslide including heavy rain or snowmelt that weakens the slope, earthquake or volcanic activity that shake the ground, human activity like building or cutting down the trees, water change in stream or groundwater. Some landslides happen underwater called submarine landslide, and this can even cause tsunami which can damage coastline. To sum up, landslide happen when something makes the slope unstable, causing rock, dirt or mud to slide down the hill or mountain. So let me look the location of landslide. This is at the Batang Kali, Selangor. Faz's Organic Farm is located 15 outside Batang Kali, Selangor, near the Titiwangsa Range, about 15 north of Kuala Lumpur and 15 from Genting Highlands in Pahang. The farm applied for an organic farming license in 2019 but has been running a campsite since 2020 without a required license because Batang Kali is close to Kuala Lumpur and popular during school holiday in December, so that many families visit the area for recreation. So this is the creative name of our landslide is Tragedy Batang Kali. This has happened in 16 December 2022 at the Faz's Organic Farm, Batang Kali, Selangor, Malaysia. So now I want to tell you about history of Batang Kali landslide. On the evening of 15 December, 92 people were at campsite with 81 registered to stay overnight. Most were families, but there were concerns that the numbers might be inaccurate because children under 4 didn't register. In the early hours of 16 December 2022, a landslide hit the near Batang Kali, Selangor, burying the campsite and trapping 92 people. 31 people were died, 61 were rescued, and 8 were hospitalized. By 17 December, Rescue Director Norizam Khamis said the chance of finding anyone alive was slim, but survivors might be still found. They were near the trees or large rock that can provide air pockets. Search efforts paused due to bad weather but resumed the next morning with excavator working to remove debris. Thought no new survivors were found. On 19 December, 125 people, including 11 excavators, 9 tracking dogs, joined the search. They focused on 5 spots identified by radar, but remaining 9 missing people were not found. On 21 December, after discovering the 26 body, the authorities ended the search in Farmview area. Next is a type of landslide. We have a 7 landslide. Is first rockfall. Rockfall is a abrupt and swift rockfall from the cliff or steep slope. This is because weathering, earthquake or freeze-thaw cycle are frequently the cause. Second, debris flows. Debris flows is a mix of rock, dirt, water, and organic matter that move quickly. This happens because typically triggered by heavy rainfall, rapid snowmelt, or volcanic eruption. Third is rotational flows. This is a downward and outward movement of material along the curved surface. This is happen when occur with frequently in region with saturated soil or with stratified rock. Next is earth flow. Earth flow is saturated soil or other materials slide down a slope slowly to moderately. This is because often occur after prolonged rainfall during the thawing periods. Next is transitional slide. Transitional slide is a material travel along the level or moderately sloping surface. In this kind of slide, this is often happen triggered by saturation, earthquakes, or human activity. Next, then is lateral spreading. Lateral spreading is type of landslide that occurs on gentle slopes where the ground moves laterally. This is happen frequently about the earthquakes of liquefaction of thick soil. And lastly is complex landslide. Complex landslides involve a number of distinct landslide type of happening simultaneously. This is often happen a result of multiple triggering factors such as heavy rainfall followed by an earthquake. So now, let me move to another member to tell you more about Batang Kali landslide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afika binti Amran, 16 DKA 23F1039. Today I would like to talk about factors of landslide at Batang Kali. Almost every landslide has multiple causes. Every factors contribute to slope failures. Slope movement occurs when forces acting downslope, which mainly due to gravity, exceed the strength of the earth materials that compose the slope. Causes include factors that increase the effects of downslope forces and factors that contribute to low or reduced strength. Landslide also can be initiated in slopes on the verge of movement by rainfall, changes in water level, stream erosion, changes in groundwaters, earthquakes, disturbance by human activities, and so on. The main reason for this landslide that happened in Batang Kali is because of heavy rainfall. This heavy rain caused the slope failure, resulting in the camping site covering the hill view, farm view, and riverside areas, which are buried in soil, causing damage to property and loss of life. According to the Straits Times Asia, the rainfall event triggering factor as a result of the combination of the amount of major cumulative rainfall for a period of 5 days and the antecedent rainfall cumulative for 30 days before the collapse occurred. This is the slope profile under here. Slope profile landslide on Batang Kali. Next is general factors of landslide. The first one is natural factors, which is geological factors. Soil type. Certain soil types such as clay are more prone to saturation and instability. Rock structure and slope gradient. Steeper stones are generally at higher risk of landslide. The second one is hydrological factors, which is rainfall and groundwater. Rainfall, it will increase soil saturation and reducing stability. Groundwater, the higher the rate of groundwater, the higher the pore water pressure. The third one is topographical factors, which is slope shape and elevation and relief. The last one is seismic activity, which is earthquakes and volcanic. Earthquakes. Ground shaking can trigger landslide, especially in already vulnerable areas. Volcanic eruption can cause landslide through the rapid melting of ice and snow, as well as ash deposition. Next is human-induced factors. The first one is land use change. Deforestation. The removal of vegetation decreases root stability and increase erosion. Urban development. Construction activities can destabilize slopes after drainage patterns. Second one is soil manipulation, which is excavation and fill material. Excavation. Digging or removing soil can weaken slopes and create unstable conditions. Fill material. Placing fill can increase weight and lead to slope failure. Third one is water management. Poor drainage system. Ineffective drainage system can lead to water accumulation on slopes. Irrigation. Next, last one is mining activities, which is surface mining and underground mining. Underground mining may cause subsidence that leading to surface instability. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah binti Muhammad Yusri. Number matrix 16DKA23F1043. So today we're gonna do a presentation about our case study. So what's in situ soil test? In situ test can be performed to identify soil type, engineering parameter and estimate soil quality. They can also be used to analyze the ground strain and bearing capacity. They have 7 type in situ test that can be performed. Firstly is standard penetration test. Standard penetration test used in geotechnical investigation to assess the relative density and angle of shearing resistance of cohesive soil as well as the strength of stiff cohesive soil. And the second one is plate bearing test. Plate bearing test is suitable for soil not cohesive. So the objective of plate bearing test is to determine burden strength, carry length and land deposit, and to determine the ultimate bearing capacity of soil at that deep. Third is comb penetration test. Comb penetration tests are conducted for soft sensitive silt and clays and some coarse cohesive soil. The objective is to measure and evaluate soil type, shear strength parameter, and relative soil density and in situ stress condition. And then is shear vein. Shear vein is a technique for determining the undrained shear strength of cohesive soil. The shear vein test is a faster and less expensive method. And then is pressure method. Pressure method measure the strength, stiffness, and strength of the ground by expanding a cylindrical membrane in the ground. So the test involves inflating the membrane with hydraulic or pneumatic pressure of monitoring and pressure and radial displacement. And then is structural load test. Structural load test is a method that involves applying control load to a structure to determine its response. Load testing, this also can help verify the design, assumption, identify potential flow, and evaluate the serviceability and durability of structure. And the last one in situ test that can be performed is dynamic load testing. Dynamic load testing is a method for evaluating the load carrying capacity of a foundation pile by applying a dynamic load to the pile head and measuring the result. A hammer or drop a weight strike the pile head, creating a compressive stress wave that travel down the pile.
Next, we calculate factor of safety using total stress method. We draw the slope diagram and determine the area, which is A equal to 189 meters square and theta is 74. And then we make a calculation. Gamma is 13.6 kilonewton per meter cube. Theta is 74. C is 26. D is 11.7 meter. So FOS formula CU R square theta over WD. W is gamma multiplied by area. So 26 multiply 30 square 74 multiplied by pi over 180 because we want to convert it to rad, and then divide by 13.6 multiply by 189 to determine W, and then multiply by D 11.7. So FOS that we get is 1.005, which is more than 1. So it is, the slope is good.
Assalamualaikum, my name is Dura Adana binti Murad. My matrix number is 16DKA231048. Next, I will tell you about proposed prevention and solution. For the first one, we have improving drainage system. Install drainage channels. Construct drainage system to control water flow and prevent water build-up on slope. Use retaining walls. Build retaining walls with proper drainage to stabilize slope, especially in areas prone to heavy rainfall. Second, slope stabilization technique. Revegetation. Plant trees and vegetation on slope to strengthen the soil structure with root network, reducing erosion. Terracing and benching. Modify slope into terrace to reduce dampness and manage water runoff, decreasing landslide risk. For the third, we have enhanced monitoring and early warning system, real-time monitoring. Use sensor to detect change in slope movement, soil moisture, and groundwater levels. Early warning system. Develop alert system based on monitoring data to warn communities and authorities in case of potential landslide. For land use planning and zoning, restrict construction, limit building in landslide-prone areas, especially for high-risk activities like large developments and heavy infrastructure. Regulate camping site. Ensure camping and recreation areas are in safer zones, not near steep slope or area with a history of landslide. 5. Regular maintenance and inspection. Slope and infrastructure inspection. Perform regular checks on roads, drainage system, and retaining structure in landslide-prone regions. Debris clearance. Clear debris that may obstruct water flow and aid way to slope, reducing landslide risk. 6. Education and community preparedness. Public awareness program educate community of landslide risk, evacuation plans, and safe practice during heavy rains. Emergency drills and evacuation plans. Conduct regular emergency drills and establish clear evacuation routes to prepare residents for potential landslide. For the last one, soil nailing and ground anchor. Use soil nails and anchor. Install steel soil nails and anchor into slope to increase stability. This technique strengthens the soil structure and reduces landslide risk, especially on steep slope. That's all from me. Thank you.
For conclusion for our case study is finally this case study on the landslide event give useful information about the elements that contribute to its occurrences, such as geological, hydrological, and human effects. Understanding these characteristics reveal the intricate relationship that make particular area more prone to landslide, such as heavy rainfall, steep slope, loose soil, and human activity like deforestation or construction. The impact of the landslide include loss of life, property damage, and destruction to local ecosystem, underscore the need for proactive measures. Key recommendations include enhanced monitoring system to provide early warnings, land use planning to avoid construction in high-risk areas, and reforestation effort to stabilize vulnerable slopes. By implementing these mitigation strategy and promoting community awareness, future risks can be minimized, helping protect life and infrastructure. This case study emphasizes the importance of a multidisciplinary approach and combine science, policy, and community engagement to effectively manage and reduce the impact of landslide. Thank you. That's all from us.